Okay, in 5.2, we're going to look at negative exponents and also scientific notation. All right, so for any non-zero base x, if we have x to the negative n, we can get rid of that negative exponent by moving the factor that has the negative exponent from numerator to denominator or denominator to numerator, just depending on where it is. So if we have x to the negative n, that's equal to 1 over x to the n. Okay. If we had 1 over x to the negative n, we can still make this positive by just rewriting it in our numerator, x to the n over 1, or we just write it as x to the n. Okay, no matter where that negative exponent is on that factor, I can make it positive by moving it from the numerator to denominator or denominator to the numerator. All right, so let's see how we can apply that, because we don't usually like to leave our expressions with negative exponents. So we're going to try to rewrite some expressions without using negative exponents. Assume that all variables represent non-zero real numbers. All right, so I've got 8 to the negative 2. I'm going to rewrite that as 1 over 8 squared. Okay, that gets rid of the negative exponent for me. And then we can go on and say that this is 1 over 64. A to the negative 9 is going to be 1 over a to the 9th. That's it. We prefer to leave it with positive exponents, so we're just starting kind of light here. Now, in C, pay close attention. Negative 8 is only on the x, so that's the only thing I'm concerned with. I'm going to leave the 6 alone, so we get 6 over x to the 8th. I'm only moving the factor that has the negative exponent. Okay. All right, so what do we get in D? Very good. Negative 12 over m to the 6th. All right, then in E, we get what? 28x to the 7th. I can bring that negative, the factor with the negative exponent out of the denominator. Bring it back to the numerator, and I'll make the exponent positive. Okay. What about F? Okay, 1 up top. Very good. Okay. Y to the 4th is fine. I don't need to bother him. The only thing I needed to move was the x to the negative 10 factor. So we moved just him. All right, just because I move one doesn't mean I have to move them both. We're only moving the factors that have the negative exponents. Okay. All right. You ready to tackle G and H on your own? Okay. How many people got those answers? Or that answer? Okay. All right. And then for H, we've got a cubed, c to the 4th, d to the 9th over b cubed. Okay, questions about that? Um, just whatever we moved to the bottom and whatever was already there, unless we moved it away. So, for instance, I had to move z to the negative 4 because I needed it to have a positive exponent. But then was to the negative 5th, so he came to the bottom. Okay, same thing over here. We had b to the negative 3, so it's on the bottom. Both of these moved because they had negative exponents. Okay. All right, using the rules of exponents, with negative exponents. Okay, all of the properties of the exponents described in the previous section hold true for negative exponents. So we don't have a new set of rules for negative exponents. Okay, all of the same rules still apply. So we'll try some of those rules. Okay, with some factors that have negative exponents. Okay, it says simplify the expression. Write the result without using negative exponents. Assume that all variables represent non-zero real numbers. We'll apply the rule first, ignoring any negative exponent, and then if we have negative exponents in our result, then we'll make the adjustment. Okay. So here we have x to the 8th times x to the negative 17. What do we do with the exponents? Add them. Okay, when we have a product and the bases are the same, we add the exponents. So we get x to the negative 9. Is that right? Okay, but I don't want that negative exponents to stay, so we're going to write it as what? 1 over x to the 9th. Okay. All right, then we got b to the negative 13 times b to the 31st. That gives us b to the what? To the 18th. Okay. All right, do we need to do anything else? No, we're done with that one. Okay. Now, and there are a couple of ways to do it, but this was fine. We also could have said, okay, we got b to the negative 13 times b to the 31st. I could have moved this at first. We would have had b to the 31st over b to the 13. Then we would do what? Subtract. And so that should still come up to b to the 18th. Okay. All right, n to the negative 14 times n to the negative 21st. What do you want to do first? Add them. Okay, so if we add these, we get n to the negative 35. And then what? 1 over n to the 35th. Very good. All right, in D, we've got x to the 11th raised to the negative 4. So that gives us x to the negative 44, right? Using that power rule. To get rid of the negative exponents, we say 1 over x to the 44. All right. Okay, here we've got x to the negative 9 raised to the negative 2. It's x to the 18th. So that's it. We're done. Okay. In F, we've got all of these factors raised to a power. So we get x to the negative 3. A couple of ways we can do this. What do you think we should do? Okay, all right, so just go on the way that I'm going. That's fine. So we get x to the negative 3 to the negative 7, y cubed to the negative 7, and then z to the negative 2 to the negative 7. So we get x to the 21st, y to the negative 21st, z to the 14th. So we're going to end up with x to the 21st, z to the 14th, over y to the 21st. Questions about that? Okay, great. All right, why don't you try G, H, and I on your own? Okay, I've got negative 2 to the 5th, x to the 20th. I'm going to kind of skip some steps. We multiply the exponent, right? Once we distribute the 5 to x to the 4th, then x to the 4th to the 5th is x to the 20th. We get b to the negative 30th and c to the negative 35th. Okay, I've got negative exponents here, So those will go in my denominator. And then we get negative 32x to the 20th. Okay, questions about that one? Okay. Here, I'm going to subtract my exponents. So I get x to the 8 minus negative 8. That's just x to the 16th. You could do that as well. We could move x to the negative 8 to the numerator and then add exponents. Well, right, if you subtract it, it's 8 minus negative 8. Right, now if we had x to the 8th over x to the 8th, that would be x to the 0, which of course we said is 1. Okay. 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 All right, and then in I, we've got 2 to the negative 3, x to the negative 24, and y to the negative 15. Okay, and so this is going to give me, well, I'm going to flip everything because everybody has negative exponents. So I get 2 cubed in my denominator, x to the 24th because it had a negative exponent, and then I'm moving y to the 15th to my numerator. Yes. Yes. So we're going to say y to the 15th over 8 x to the 24th. We want to work out that 2 cubed. And before we can evaluate a real number to a negative power, then it helps us to get that power as a positive. Okay? Because what happens when you talk about 2 to the 4th, 2 to the 6th, 2 to the 8th, those things are getting bigger, right? But then when we use the negative exponents, they're getting smaller. So negative 2, or rather 2 to the negative 1, let me write this down, is 1/2. 2 to the negative 2, if we said 1 over 2 squared, that's 1/4. 2 to the negative 3 is 1/8. So when we're raising it to a negative power, it's a fraction, right? And these exponent rules, I mean, they just kind of start to run together. So you got to really, really, really practice them, be clear about it, when you're using them, because you'll see them a lot, in this chapter. Okay. All right, very good. Let's talk about scientific notation. Okay, rewriting a number in scientific notation. To convert a number to scientific notation, rewrite it in the form a times 10 to the b, where 1 is less than or equal to a is less than 10, and b is an integer. So what this does is it forces us to have just one digit in front of the decimal place. Okay, so if we explore powers of 10, and we kind of did this a little while ago with some other numbers. Okay, what do we get if we multiply 31.415 times 10 to the first? Okay, so we get 314.15, right? And then if we do it times 10 to the 2, it becomes what? 3141.5, right? Try this out on your calculator if you're not certain about it. Okay? Then if we multiply 31.415 times 10 cubed, we get 31,415. And then here we get 314,150. Okay, and then one more. Am I right? Okay. All right, so when we multiply a by a power of 10 raised to a positive exponent n, the decimal point moves in places in which direction? to the right. Okay, so when I multiplied, let's say 31.415 by 10 cubed, then our new number moves the decimal place 1, 2, 3 spaces to the right. We got 31,415. Okay, so multiplying by the positive, or 10 raised to a positive exponent, moves decimal point to the right. Okay, if we do it with the negative exponent, okay, we get 31.415 times 10 to the negative 1. That's going to become 3.1415. Okay, if we do it times 10 to the negative 2, it's going to be 0.31415. Okay, and then 0.031415. And then if we move it, multiply it by 10 to the negative 4, we get 0.0031415. And then here, 0.000311415. Okay, multiply those out on your calculator just to make sure that that's what you get. Okay, so we see a pattern here. When I multiply it by 10 raised to a negative exponent, we move the decimal place, or the decimal point, 3 spaces to the left. Okay, so when we multiply base by a power of 10 raised to a negative exponent n, it moves the decimal point n places to the left. Yes.
On the calculator,
Uh-huh.
I know you can do it where you leave, you don't have to do that, where you can just do say 3.14,
Uh-huh.
raising it to the 10th. There's a button that actually says it's raising it to the 10th power.
It is this EE. Yeah, EE. So if you want to say, what was our number? 3.145, was it? 1415? Okay. We do second. On the comma key, there's that EE. It only shows one E on the screen, but let's say we do 3. So that's 3.145 times 10 to the third power. Okay. Other questions about that? All right, so now we want to convert these numbers to standard notation. We can see that they're all in scientific notation, okay? And so because we've got the base being between 1 and 10, and then we're multiplying it by some power of 10. And we know now which direction this moves things in. For instance, in A, we got 3.07 times 10 to the 5th, so the decimal point is going to move where? 5 places to the right. So we got 3. This is 1, 2, 3, 4, 5. Okay, our decimal point was here, but now it's 1, 2, 3, 4, 5. It's going to be out here. Okay. So we get 307,000. All right, in B, we're going to move which way? To the left. Okay, so we get 1 space goes there in front of the 2, and then we need how many zeros? 3. So 0.00023. Okay. All right, in C, we're moving 8 places to the left. So I'm going to use how many zeros? 7 zeros. So, because one of my spaces gets moved up or used up, moving the decimal from behind the 6 to in front of it. So that's 1. I need 7 more moves. So 1, 2, 3, 4, 5, 6, 7, 6, 0, 0, 1. Okay, and then this one, we need 10 moves, so 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if we're going from scientific notation to standard notation, then That's pretty easy. Just make sure we move the appropriate number. And don't forget, with this one, when we're moving to the left, one of our spaces gets taken up by moving the decimal on that first move. So we only need one less number of zeros. Okay. Questions about that? Okay. All right. Well, what if we're trying to convert a number to scientific notation? All right. Well, I've got some step-by-step instructions here. Okay. Convert the given number to scientific notation. We've got 7,200,000. It says first, we're going to move the decimal point in the given number so that there's only one digit before the decimal point. So we've got 7.2. Very good. Okay, now we need to multiply the number from step 1 by the appropriate power of 10 that would take it back to the original number. We have to reconstitute it. Okay, so we've got 7.2 here, but I need to get to this thing. If my decimal is right here, how many places do I need to move so that I can have this number? 6. We're going 6 to the right, so it's going to be times 10 to the positive 6. Okay, establish your base first so that it's between 1 and 10, and then we think about what do we need to do to this base to get it back to where we started. All right? Yes?
Is there any time scientific notation will not be raised to the 10th power?
Nope, scientific notation is always times 10 to the power. Okay, good question. All right. Over here in B, first thing I'm going to do is write my base as what? 6.21. Okay. And then think about, okay, if I'm at 6.21 and I need my decimal point to move over here, I'm going to multiply by 10 to the what? Okay, it's going to be negative because we're going to the left. 1, 2, 3, 4, 5, 6 places. So 6.2 times 10 to the negative 6. Okay. All right, questions about that? Now we will see in just a minute that we can multiply and divide numbers while they are in scientific notation. We don't have to put them in standard form first, and that's what makes scientific notation so convenient. Okay, so I think we want to try some of these. We want to write these in scientific notation. I'll do C and D, and then let you try E and F on your own. Okay, so for C, our base is going to be what? 1.35. Okay, times 10. I need my decimal place to move which way? To the left. So it's going to be 1, 2, 3, 4. We say 10 to the negative 4. Okay. So 1.02 times 10 to the what? Second. We need our decimal point to move 2 places to the right. So positive 2. 10 to the positive 2. Okay, so quickly take a look at E and F. Okay, I got 9.2 times 10 to the 4th. Okay, and then 3.45 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. Okay, all right, questions about that? Okay, very good. Okay, so let's talk about these operations on numbers in scientific notation. When we write a number in scientific notation, all of these things are real numbers. So when I look at 5.8 times 10 to the 4th and 5.2 times 10 to the 9th, okay, all of those, I'm sorry, 3.2 times 10 to the 9th, all of these numbers are real numbers. They're just real numbers. So we can multiply real numbers in any order. The order doesn't really matter. So it says we're going to rearrange these factors, placing the bases of 10 together. Okay, so I'm going to rewrite this as 5.8 times 5 or times 3.2 times 10 to the fourth times 10 to the ninth. Okay. And then I'm going to use my exponent rules on 10 to the fourth and 10 to the ninth. That just gives me 10 to the what? Okay, 10 to the 13th. And then I might multiply on my calculator 5.8 times 3.2. That gives me what? Okay, 18.56. Now, is this number in scientific notation? No, because the base is not between 1 and 10. So it says if necessary, move the decimal point so that the base is greater than or equal to 1 and less than 10, and then we're going to adjust the exponent on 10. So I'm going to do 1.856, and I'm going to think about what do I need to do. I need to add one more exponent, right? I need to move this decimal point one place to the right. So that means add one more to my exponent, 10 to the 14th.
Why do you say it'd be adding one?
Because, okay, we're trying to get back here,
Okay, okay.
right? We're here and we're trying to get back to that one. Okay. So to move it to the right, we need to have positive, one positive one. Okay. Let's look at it on the other side. Okay, we got 3.286 times 10 to the 14th. We could look at this as 3.286 divided by 6.2. Okay, and then we got times 10 to the 14th up here times 10 to the negative 7. Okay, I can divide these two and then use my exponent rules to handle those two. Okay, so 3.286 divided by 6.2 is what? Okay, 0.53. Okay, times 10. What am I going to do with the exponents? Subtract. So we get positive 21, right? 14 minus negative 7 is positive 21. Okay. Now I say, okay, well, this is not the base that I need. I need this base to be between 1 and 10. So we get 5.3. But to get back to this, I need my decimal point to go which way? To the left, 1 to the left. So we're going to subtract 1. So we get 10 to the 20th. Okay. Yes. Explain which part again? Here? This. Okay. I rewrote it. We had 3.286 times 10 to the 14th divided by 6.2 times 10 to the negative 7. Okay. I can do the division with these, do the division with these. We're still multiplying when it's over. So, okay, so when he did 3.286 divided by 6.2, we got 0.53 on the calculator. Is that okay? All right, good. All right, other questions?
So pretty much if the division, the way it's gonna work, if it's in division, it's gonna move to the left. So you're gonna subtract one. If you're adding,
No, 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 no. We can't make that generalization because if, let's say, this had been a positive 7, no, 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 no. Let's say this had been, let's say the 6 had been on top. Then the number, the base would have come out to be between 1 and 10. So, yeah, no, it's not just because we did division, we subtracted. You got to look at whatever it is you come up with every time and figure it out. Okay. All right, very good. Okay, I'm going to let you try those two on your own. Okay, so you multiplied 3.6 times 1.6, and we get what?
5.76.
Okay, 5.76. And then I'm going to add the exponents on my tens. We get -7. So we don't have to make any adjustments to that one. Okay. All right, then 6.0 divided by 7.5 is, okay, zero point 0.8. All right, 0.8, zero point 0.8 is fine. We're going to subtract the exponents on the 10. We get 10 to the 25th. Very good. Okay, I need this decimal point to move 1 to the right, so we get 8. Wait, wait, wait. Wait, I'm going to write it as 8. Okay, then to get back here, I need it to move which way? To the left. So we get to the 24th. Okay, 8.0 times 10 to the 24. All right, each day Burger King restaurants serve 1.57 times 10 to the 7th customers worldwide. How many customers do Burger King restaurants serve in 1 year? Okay, so how would we solve this? Okay, very good. 365 times 1.57 times 10 to the 7th. Okay, but they're all real numbers, so I can multiply them in any order. 365 times 1.57 is what?
573.05.
Okay, 573.05 times 10 to the 7th. They didn't say which format they wanted in, and we scientific notation is nice, but if we write it out in that standard form, that's probably more meaningful to people who don't deal in scientific notation every day. So since they didn't specify, I'm going to move my decimal point how far? 7 places to the left. So 0, 5 is the 1 and 2, 3, 4, 5, 6, 7. So I can say 5,730,500,000 people every year. Right. Yeah. If we were going to leave it as scientific notation, I'd say 5.7305, and then to get back to here, I need two more, right? Okay, so it'd be times 10 to the ninth. Okay.
Just asking for a specific amount of customers, so you can kind of assume that it's not going to be an equation too.
Right. Well, yeah. You mean
Or not
not in
not
scientific notation, right? I mean it's a number, but we just don't normally talk that way, you know. So I would think that this would be better. In applications, often this is better.
Oh, that's an eyesore compared to the other way it looks.
It's an eyesore. Which one?
Oh, that's a
This
lot.
is that's why we have scientific notation. So it's really important, talk about how far it is from here to wherever, the moon or the sun, or how long it would take to get there. Those are very large numbers. So sometimes they deal with very small numbers, and so it's easiest to write them in scientific notation. Okay. All right. So the speed of light here it is 1.86 times 10 to the 5 miles per second. That's just fast. How far can light from the sun travel in 10 minutes? Okay, so this is the rate per second. Very interesting. So 1.86 times 10 to the 5. Okay, that's miles per second. Okay, so that's in 1 second. I need 10 minutes, but minutes and seconds don't cancel out, right? So how am I going to get those to um, cancel? Okay, so we can say 1 minute. I'm going to put minutes on the bottom because right now we've got minutes up top, right? We can assume this is over 1, and I'm going to want minutes to cancel, okay, is equal to what? 60 seconds, right? Okay, and so the seconds also cancel. And so what am I going to be left with? Just miles. Okay, so that's how I know that that works out fine. Now we're ready to do it. We've got 1.86 times 10 to the 5 times 10 times 60. What I would do, I would probably multiply the 1.86 and the 60. Okay. Well, we could multiply the 10 by the base 10 that we already have.
No, I'm saying times 60 then times
Yeah, but I'm saying instead of getting that tied up in here, I'm going to just take this 10 and put it with this one. So 1.86 times 60. Okay, 1.86 times 60 gives me 111.6 times 10 to the sixth because I get one here and one there. Okay, that's still not scientific notation, but that makes it a little bit easier, a little bit. You didn't have to do that, but we could do it because they were tens. And then if I want to write this in scientific notation, okay, what do we need to do? Two more. So to the eighth. Okay. And this is miles.